So we're going to talk about aerial data capture, drone technology, photogrammetry. I'll start off with a little bit of a warning that it's not the panacea that people may think it is. And it's just a little cautionary tale. So everybody loves photos, be it your granny, whatever, and the old adage used to be that camera never lies. But we've now got AI technology, and the camera can lie, because quite clearly that dog is not driving a Formula 1 car. So it's that taking what we can do, what we used to take as being known truths in the past, and say, well, there's a photograph, and it's photographic evidence. Sometimes it can be manipulated. Not always bad, and we're going to go and show how we can manipulate photographs for our own benefits. So what I want to talk about is photogrammetry. I don't go into a great deal of detail of the science behind it and the maths behind it. It's fairly complex. It's just to give you a flavour that it is fairly complex. And if you get it wrong, you get the wrong answer. And if you don't put your checks and balances in place, you don't know you got the wrong answer, so you're working with the wrong data sets. So that's kind of the basic principles photogrammetry has been about. It came into really sort of World War II, I think. World War I, World War II was at the time when it really came into being used as a technology for whether it was good or bad. It depends on your point of view. But as an emerging technology, that's sort of where we came from. You can use a single image. You can extract data from a single image. You can also use multiple images. And when you've got multiple images, you can look at depths and things like that. So there's a little thing there to test, which is called stereoscopic parallax. So anybody who's used a theodolite or a dumpy level, you would be used to using, you'll know what parallax was. So what I want you to do is, as you can see there, just close one eye and extend your finger so you're covering one of those cameras. Okay, now swap eyes. And you'll have seen the point that you shifted. So that's what we use in photogrammetry. That's how we perceive depth. Initially, I was going to get somebody up and throw something at them, but I decided that probably wasn't safe enough anymore. And it's quite a small stage compared to the ones in London. So I decided not to, and it works just as well. It's quite a good analog. So there's no wrapping of beach balls this year. That's the only bit I'm going to be doing. So, sources of error. That's the bit that I really need to talk about, the bit we need to focus on, the bit where we can get things so massively wrong in a photograph. And if we don't if we don't understand it and we take that as being the right thing, then we're making decisions based on poor data. And as we all know, that's not a good place to be in. So one of the other sources of errors we've got, is we're using drones. Drones are fantastic things. They're nice and light. But the technology, a cheap drone and a dear drone, some drones are consumer grade, some are really high level. And depending on where you spend the money, depends on your sensors, depends on your optical clarity. So what I've shown there is try to show that photogrammetry in itself is based on similar triangles. It's that fundamentally simple. But if you've got an aberration in your lens, your similar triangle on the ground is not your similar triangle inside the lens. So you're bringing in error. And I've got some slides coming up next which kind of show that. We've also got GPS, and I really should have brought my glasses to read this. Oh, there's a big one there. I'll just move over here. So we also use GPS for positioning. But we're positioning something in the sky. It's got gimbals, which has got angle resolutions. That angle is wrong by a few degrees. If you're flying at 200 meters, that's going to increase and compound your errors. And you just keep on building error on error on error, and they end up with something that just doesn't work. So this is East Kilbride car park for the Scottish people. Didn't think anybody would recognise it, but you never know. And it's the same point. So we're looking at the blue circle and we're looking at the yellow circle in each of those images. So I've made slight changes just to show that these errors can creep in. And if we don't take them out, it makes a big change. So the one on the right-hand side, left-hand side? Aye, left-hand side for you guys. One on that side. That was as supplied. I've then made a change to the sensor height, or the flying height. And you can see there, same image, but my yellow circle's moved. So there's an error creeping in. I've changed the focal length of the camera, which is the equivalent of changing the flying height. Again, it's moved. So it's another change. And on the last one, I've put the pose data in wrong. So pose data is, as you can imagine, it's how you look. So as the camera is facing, it thinks it's facing up, when actually it's facing down. So again, it's another small change. If that's not got the right resolution or whatever, or you just have the wrong hand, some images expect 0, 0 to be the bottom left, some expect it to be the top right. So if you get those wrong, your resulting images are going to be wrong. Ground control points, that's one of the ways we try and remove some of the errors, is by using ground control points. But they're not all the same. So those are 2 points there at the bottom. Those coordinates are identical, but you can see there, they're showing they're two different entirely places, because one was a bad version of the control grid. That gets into some stuff more about transformations and mapping and stuff like that, but it can happen. If you've got a bad definition, you can get those two control points, and you can see there they are the same numbers, but they are quite different apart. So we just need to be careful that even if your control's not right, rather than trying to remove a source error, you're introducing another source error. The other thing we've got is a thing called GSD. Not that type of GSD, but it's ground sampling distance. And that is essentially if you think about how many pixels you want to capture. If you want to demonstrate what a clip looks like and tell if it's, you can see the clip, you fly at a certain GSD. If you want to see if the insulators are broken in that clip, you have to fly at a different GSD. The lower you fly, the more data you capture, the longer it takes you to capture it, the longer it takes you to process it, the more expensive it is to store it. So there's a balance again to be had of where you fly against what you actually want to capture. So these are two pretty terrible examples, because I didn't have a drone that could fly really low. You can see one is, so the one on the right, left, is 60 meters above ground. You can tell that's a Pandrel. You can't, you probably can tell it's a 401. But the same image, you can't even tell there's a sleeper there. So that gives you an idea of just how you need to balance your ground sampling distance. Now, if I don't really want to know what the clip looks like, I'm okay at 100. But if I want to know what the clip looks like, I need to fly lower. And if I really want to see the detail of the biscuits and such, I have to fly again lower cell. So just finishing off in the ground sampling distance, you can see there we've got a little drone and how many images that's taking to cover, I think that's a fire station, versus a helicopter. And it does come down to cost and balance. So you can have high detail, fly lower, bigger sensors, or you can fly higher, less detail, quicker to capture, and so on and so forth. So far, I think we've dabbled with drone imagery, but we've not really left the pretty picture phase. And there is so much more that we can do with it. And to give you an example of what else we can do with drone stuff, I'm going to hand over to Dr. Bradley.
Hi, everybody. Yeah, just to kind of pick up on from what Colin was talking about there. I guess, first of all, I'm from Network Rail Air Operations, so we operate both 2 helicopters and multiple drones all across the country. From a kind of helicopter perspective, we actually capture data for the routes and the regions. On the drone side, we actually kind of facilitate the use of drones by employees across the company. So I just wanted to start with a bit of a question for the group here. I think it's probably easiest to do this by showing of hands. So I guess, first of all, who here is aware of air operations? Can you put your hand up if you are aware? Okay, I'm pleasantly surprised by that. It's probably worth mentioning I've only been here myself at Network Rail for about a year now, so kind of still figuring out what the awareness is of the team. Maybe the next question is one I'd expect more knowledge of, so can you raise your hand if you're aware of route view? Okay, good. I think that's most of the people here. So that's great. I was potentially expecting not many people to be aware of air operations and more to be aware of route view, and now I've linked the two, but I'm pleasantly pleased to hear everyone's aware of us. So I mentioned that we kind of do two things within air operations. My role as National Drone Manager is on the left-hand side, so more kind of on the governance of drone use in the organisation. And then on the other side of the of air operations, we also have the helicopters. You can see there we have around 200 pilots within the organisation. They all have full-time jobs and do that as just a capability in addition to their full-time job. And that actually makes us one of the biggest drone operators in the UK, if not the biggest. That's quite an undertaking, and it's kind of grown organically, I guess, but we're delivering all sorts of interesting insights and capturing really interesting data using drones. So looking at how we govern that and how the operating model works is of utmost importance, really, as we move forward. Obviously, the previous presentation was all about technology and R&D, and that's something we're certainly keen to engage with. In addition to our own internal capability, we also have a framework of contractors that can deliver services. So anybody can buy those services today. There's 4 contractors on that framework. Off the top of my head, they are Bridgeway Consulting, Remote Aerial Surveys, Plowman Craven, and another one who aren't so active, they're kind of like in the water industry. So yeah, if anyone wants more information on that, then we can provide that. Please do reach out and get in touch. And then on the other side, we have the helicopters, which I briefly alluded to. So we have 2 of those. They are provided by an external provider, and the pilots don't actually work for Network Rail, so we just contract that in as a service. But what we do is provide the 6 observers that work on the helicopters to go out and capture data of the infrastructure. And kind of some of the deliverables from that include route view, asset inspections, route proving, point seating inspections, particularly at this time of year, OLE inspections, stuff like that. So helicopters and drones offer 2 different things, really, in terms of data capture. As you can imagine, helicopters, at the moment at least, cover large areas. They can do large-scale inspections. So OLE, for example, they can use thermal cameras to capture data of the OLE, and P-way as well. They're good at capturing data for if there's a large quantity of assets over a wide distribution or over a wide geographical area, so they're good for that kind of stuff. They also provide kind of response to weather events, so when you've got flooding and stuff like that, or during kind of critical national events, so recently the Queen's Jubilee and funeral, making sure the railway's operating efficiently. Drones, on the other side, kind of offer more in terms of small-scale ad hoc inspections, so you can do stuff like OLE, P-way inspections, look at clips and sleepers and railhead conditions in the autumn. You can look at leaf fall, all that kind of stuff. Relatively small scale at the moment. You can also use them internally. So I don't know if this has a pointer. You can see this kind of drone here in a cage. They can be flown in culverts. They can be flown in tunnel shafts, those kind of environments. So like lots of different capabilities available with drones. They're also good for incident response. So we've seen increasingly the use of drones for like response to trespass incidents and stuff like that. So drones are typically used for photogrammetry, but I just wanted to show a brief example of photogrammetry that's been done from the helicopter. So this is just a series of images that have been taken by the helicopter and stitched together, and you can see they cover a good portion of track there. But typically, drones are used for photogrammetry. One of the biggest kind of challenges, really, with drones is regulation. It's actually quite a complex regulatory environment, And this does kind of hold back the use of drones fully to the full potential at the moment. So we have currency requirements. So I mentioned those 200 drone pilots we have. They have to make sure they're flying 2 hours every 90 days to keep in compliance with Civil Aviation Authority requirements, and that can be quite tricky for certain employees. We also have kind of changes in regulations around training. So the bar for competency is being increased by the CAA. So it's actually potentially getting more difficult for anybody in the company to get trained up in a part-time capacity or to do it as just a capability. And that might require the business or Network Rail to look at how we have the operating model set up accordingly. We may need to look at having full-time people to offer those services across the organisation. And one term that I want to touch on, and I'll talk a bit more in detail about, is BVLOS. So that means beyond visual line of sight. So currently you can only fly a drone up to 500 meters away from the pilot. And that's, as you can imagine, with kind of large-scale linear infrastructure, that's quite limiting. But where there will be real opportunities in the future is when you can fly drones, similar distances to helicopters. So at the moment, what the Civil Aviation Authority are talking about is kind of requirements that are more akin to professional pilot standards. So to do that ourselves is really challenging. There's also stuff around fleet maintenance as well, because these are ultimately aircraft that we're using. So the bar for that is rising as well. But these are all things we're trying to kind of get to grips with and address today. So Colin talked about the things you need to be aware of when you're using drones for complex applications, such as photogrammetry and creating 3D models and things like that. But I just wanted to touch upon quickly what our pilots are doing today, so those 200 colleagues that we have trained. So we have some relatively non-complex tasks, so things like inspections, looking at the rail corridor. Here's a photo taken, I think, about 30, 40 meters up. You can see a little red box here in the center. And you can see just from a standard drone that you can buy pretty much off the shelf relatively cheaply, you can zoom in all the way to reading a sign on the edge of that hut there. Give you a track example. Here's a zoom in, and you can kind of read plates on the sleepers and read IDs, look at individual bits of ballast, stuff like that, clips and things. So that's kind of a simple application of drones, really. You're just capturing images, sending somebody onto the track environment, keeps boots off ballast, that kind of stuff. So the next thing I had on here is, we can do this by show of hands, I think, rather than Slido. Who here is aware of the Network Rail drone framework? Has anyone used it before? Okay, a few hands, so that's promising. So when it comes to kind of complex drone applications, whilst we have those 200 people trained to do relatively simple applications of the technology today, we do have already today an accessible drone framework where people can procure all sorts of different surveys, including P-Way 3D models and stuff like that. Here's a photo of me in a previous guise. So I used to work for Bridgeway Consulting myself before joining Network Rail. Colin talked a little bit about putting out ground control points and the importance of that for survey accuracy. I have highlighted, this is a disused siding, just in case anyone's worried about how close I am stood, with my blue hat as well, which I did eventually get rid of. So what I wanted to just talk about is that these providers are available today, and they can offer a little bit more expertise in terms of capturing the data and also processing data of the rail environment. So that includes photogrammetry, which Colin talked about a little bit, but also LiDAR data, so laser scanning data. And hopefully this will work. Here's an example of a 3D model that Colin actually procured through one of the framework contractors. So I think to a pretty good survey accuracy as well, with ground control points and everything like that. So hopefully, and you'd almost be forgiven for, if you didn't have the edges, the hard edges, for confusing this with like a helicopter video footage or something like that. So hopefully that's something that's tangible in terms of the outputs from the technology. So yeah, just to reiterate, this kind of service is available today. and depending on what your requirements are in terms of accuracy, you can readily achieve band 3 accuracy. In some cases, you can get down to band 2, band 1 accuracy with drones, but you do need like a lot of control for that kind of stuff. So I'm just going to kind of round off the piece about air operations and about drone technology by talking a little bit more about beyond visual line of sight, which I alluded to earlier. In terms of R&D, one thing that we're looking at the moment is 2 trials that look at beyond visual line of sight. Now, initially, these are looking at the kind of use case of trespass. So trespass is obviously, as we're all aware, a huge issue. Lost minutes like accrue up to like huge sums of money. So the kind of business case for this application of drones is potentially really big or really strong. So we're working with 2 external consortia at the moment to provide a really kind of quite complex capability flying from the West Midlands Signalling Centre in Birmingham, so not far from here. And the initial idea around that is to be able to launch a drone at short notice and go and respond to a reported trespass incident, prove whether that's a false positive or whether there's actually somebody still in the railway corridor, pass on information to the British Transport Police and stuff like that, and be able to just respond very quickly. But the bigger picture here is that that's kind of, we're developing a capability here that is just applicable to one use case in this particular piece of R&D. The wider idea is that we'll be using platforms that can have other payloads fitted to them. So some drones that we'll be using can carry a total weight of up to 25 kilos, if not even heavier potentially. And I think there is a number of potential areas where we can do other stuff with either the same assets that are used for trespass response or even dedicated assets in the future for collecting data of the rail corridor. I've just put up a few examples there, such as frequent maintenance inspections. So, routine kind of maintenance tasks. Leaf fall railhead inspections in the autumn, looking at switches and crossings, route proving, wet bed inspections, all those kind of applications. And they're just ones I quickly plucked from the top of my head. So just the final slide really is that's a project or 2 projects that we're working on today that will probably be delivering in around 12 months' time, so next year, so into the start of CP7. What is happening today also beyond our framework is that there are contractors working, doing really innovative use of drones today. So Skyports is one company that springs to mind. They've developed a drone in kind of collaboration with a company in Norway called Field, and you can see the drone up here. This is a photo I took recently from a visit out to them, just to kind of understand what it is that they're using, the safety record, all the data on that aircraft, because obviously there's risks flying these things over our railway. That drone there with all the payloads and the batteries weighs just under 25 kilos, so there's quite a considerable mass to be flying, potentially down to 20 meters above track. But you can probably appreciate just from that photo how big one of these aircraft is. So they're using this to capture imagery that could be used for photogrammetry. It also has a thermal sensor, and you can't quite see it in the shot here, but it has a LiDAR sensor as well. When you integrate that into something such as computer vision or AI, as the cliche kind of buzzword, I guess, I think there's a lot you could derive from that data, both in the railway corridor, also looking at things like vegetation outside of the initial corridor, beyond the fencing, trees that may be at risk, geotechnics, so like embankment failures, potentially change detection, that kind of stuff. One other thing that is happening today as well, although being used during possessions for obvious reasons, is drone spraying. So we have a contractor that's able to offer spraying of things like knotweed from drones. And there's a photo of that in the bottom left there as well. Myself and Colin were just talking about some other potential applications in the future and things we've heard of in other areas. So areas around like defibrillator access, if somebody has a medical issue on track and you haven't got something readily available, could we potentially have something like that available at short notice? I've seen use of drones to deliver defibrillators in like the kind of coastal environment. So the Coast Guard have started doing trials on that kind of application down on the south coast. And also potentially tools and parts. And I touched on route proving, section proving as well, including at night. So there's some stuff that might relate to track renewals as well. And that's us, I think. Thank you very much.